In this lesson, we're looking at possible reasons why Newton's method either doesn't work or gives an approximation that's actually further away from the root, which is obviously not what we want. So in the first example here, for number 1, if we take a as our first approximation and find the derivative is going to be 0. So if you remember what Newton's method was, it's a1 equals a minus f of a on f dash of a. Now if we can't find the derivative, if the derivative of a is 0, then Newton's method's not going to work. So if your initial approximation, or any approximation, lands on the stationary point, Newton's method doesn't work. Second example here is if you take as your initial approximation a, and you do Newton's method, which is in fact finding where the tangent at a crosses the x-axis, well, your second approximation, so-called, is actually further away from the root, just dependent because of the shape of the curve. So it depends on the value you take for a, and if you choose the wrong value, then you're going to get an approximation that's further away from the root. Mind you, in all the questions you're given, you're told which first approximation to take. There was a question in this year's Extension HSC actually, and it involved a similar diagram to this, and it asked why choosing the value of a here would not give you a closer approximation to the root. And so it was a comment question, and you could also use diagrams if you wanted to. Okay, a similar style question as the last one. A is our first approximation, and if we take the tangent at a, the new approximation is further away, about the same distance, perhaps a little further away, so it hasn't really done anything in terms of locating a more appropriate position for the root. And here's a real example. So there's 3 roots here. If we try and have a look at the approximate, well, the root is -2, but if we want to take one approximation and refine it using Newton's, let's take the value of x equals -1/4. So that's going to be our a value, which, if you think about it, is before the stationary point. So given that there's a change in direction here, if you take the tangent here, that's going to hit somewhere here. So -1/4 is not a good value to take if we're trying to find the -2 root. It'll give us the other root. So this is an example of choosing an inappropriate value. So that's going to be our a. So, f of -1/4, and I've prepared it earlier, is 7.109375. You can check that if you like. I know some of you will. And the derivative at -1/4 is -3.8125. So if we plug that into Newton's, a1 equals -1/4 minus 7.109375 all over -3.8125. And if we work that out, it's 1.614. So it's a nice approximation for this root down here, but does nothing for us up here. So it all depends on the value that you take. So we've had a look at some of the reasons why Newton's method may not work. The first one, continuity. So if a curve's not continuous at the point you choose, clearly you can't find the derivative, which leads us on to this one. So there may not be a derivative, or the function may not be differentiable. You may not be able to find the derivative at a particular point, and therefore you can't use Newton's method if you can't find the derivative. Stationary points, the proximity, so that example we looked at, if it's before the turning point and the root is after the turning point, then you're not going to get the correct approximation, which leads us into choosing appropriate values. Might put an S on that, for your initial approximations.